This is the Daily Technology Pulse podcast. Welcome aboard.
Welcome to another episode of the Daily Technology Pulse podcast. Hey, it's Rick from DALY once again, and I am proud to welcome you to this episode where we're going to be talking to the folks from our strategic partner, Aruba. But before we do that, I do want to remind you that DALY is your local, trusted, comprehensive source for all of your technology needs. Whether it's audio-visual, advanced technology, printing, managed services, client and endpoint computing, you name it, we can give it to you. All you need to do is give us a call at 800-955-DAILY, or you can email us at solutions@daily.com. All right, without further ado, it's time to talk to the folks from Aruba. And we've got a team joining us today, and we're going to be talking about some fantastic technology, Wi-Fi 6 and 6E. Joining us today, we have Anthony Holland, who is the Channel Enablement Systems Engineer for the Mid-Atlantic, Jorge Garcia, who is the Systems Engineer for Commercial, and Melissa Brown, who is the National eRate K-12 Channel Manager. Welcome, all of you, to the Daily Technology Pulse.
Thanks for having us.
Thank you.
It is my pleasure to have you. So let's start with an introduction of Aruba, because I'm sure people hear Aruba and right away we start thinking of tropical sunny shores. It's certainly where I would like to be, but obviously Aruba is a little different for you, or a lot different. So can you tell us a little bit about Aruba's journey and where the company stands today?
Sure, Rick. For those of you who aren't familiar with us, we started back in 2002, 2003 timeframe as a wireless-focused vendor. And back in around 2015, I'd say, we were acquired by Hewlett Packard Enterprises, which has since put us on this upward trajectory of growth. We've since evolved into a more full-stack solutions provider, competing with the best of them today, putting us, probably I would say tier 2 in the industry. And with that, we've got a full portfolio to accommodate those various solutions, whether it's a wireless portfolio, which we're going to talk a lot about today, with some specific new technologies. We've got wired solutions, thanks to our CX switching line, which has evolved from HPE's ProCurve units. We're now looking at SD-WAN, thanks to our acquisition of Silver Peak in the last year or two. We've got a security stack solution through our product called ClearPass. We can also, provide user level insights through a tool called UXI, which we are going to highlight for you today as well. And also evolve that, leveraging all of that into a cloud-based solution we call Aruba Central. So that's our cloud-centric platform, single pane of glass, leveraging AI models to help predict and troubleshoot issues as they may arise. So again, very diverse portfolio as it stands today. And, we're only continuing to grow that path forward in the coming years.
Well, fantastic. And thanks so much for that background on it. And obviously, Aruba has been a valued partner of DALY. I understand that today we're going to be focusing on some exciting new wireless technology. And I really want to know the answer to this, because I have heard these terms thrown around quite a bit. And one of them is Wi-Fi 6, and then the other one is 6E. So can you tell us more about those and how they differ?
Absolutely. So, and yeah, I'm totally with you there. Even us engineers are, very confused by some of these terms that get thrown around today. And to IEEE's credit, they tried hard to kind of reduce some of the confusion around protocol names. When Wi-Fi first launched back in the early noughts, it was 802.11b, right? Which was, which became the superseding component to 802.11a, right? And then we had G, and then N, and AC, and it's only gotten more and more confusing for the average person, right? So then they introduced this kind of numeric structure, kind of retrofitting, I would say, 802.11n with Wi-Fi 5, right? I believe, or sorry, no, Wi-Fi 4. Then 802.11ac, which has been around for the better part of the last decade, right? That would be what they call Wi-Fi 5. So today, I would say in the last few years, I think it was ratified around 2018 timeframe, we got Wi-Fi 6. So that would be what they call 802.11ax. So there's a bit of a decoder ring in there. Totally Googleable if anyone needs to find it. But the key thing to know is today, Wi-Fi 6 is where we're at, right? So when you hear that, know that means leverage. It's still a 2.4 and 5 gigahertz standard, but what we're doing is making more efficient use of that spectrum. So for many years, wireless has been trying to catch up to Ethernet in terms of capacity, in terms of speed, throughput, that sort of thing. But there was a coverage focus as well, being able to cover a space as needed. But now the focus is more on that capacity. So how do we, cram 90 to 100 plus people in a conference room on a single AP or two and make sure that they don't overwhelm those devices with 2 or 3 devices per person. So again, efficiency is the goal with the Wi-Fi 6. Now 6E is really exciting. It's an extension to that existing standard, and that it's opening us up to the 6 gigahertz spectrum. So that was a brand new slice of spectrum that was recently approved by the FCC. Only for indoor use so far. We're still working on getting outdoor approval because there are some things out there like fixed satellite stations, microwave antennas, news trucks with big antennas that do news gathering. That stuff kind of does tend to interfere along with like some public safety things. So they're still working on mitigating a lot of that. However, for indoor usage, there's a few different classifications that really enable it to be streamlined so that we can actually leverage that band now, which is an order of magnitude larger than what we've had before. Just to give you an idea, 2.4, originally had 3 usable channels essentially, right? So 5 kind of, brought even more to the table of 25. And now with 6, we're getting 59 channels. So it's an effective game changer there. And a lot of that's being driven, of course, too, by the fact that, sources like Gartner are telling us now that we're crossing 6 billion devices globally. I mean, it's a huge staggering number when you think about it. And Wi-Fi is no longer it's no longer a luxury. It's something that we have to have in our businesses today. So a lot of these channels are just getting overly saturated, even in the 5 gigahertz spectrum now. So 6 gigahertz has really come along at a good time to help us, take advantage of a clean RF, and we can kind of start from scratch almost when it comes to wireless in a way that is going to really shake things up. Yeah, we're talking about getting over the 2 gigabits threshold potentially.
That always was the big thing about Wi-Fi, just to liken it to a home network, where I was paying for a gigabit connection, but I really was only getting about, 100 to 150 Mbps. But now you have these routers where, again, they use the Wi-Fi 6, and now you're getting up into the 5, 6, 700 range. So
exactly. So and that's, and I don't know about you, but me personally, I've got a 1 gigabit Fios connection now. So the closer I can get to that, the better, because I don't have to worry about bottlenecks as much as I used to. But and there's some key features too that Wi-Fi 6 introduced as well. I want to touch on real quick here, if I can, that really showcases some of the key things that we're able to do thanks to this new standard, right? So, and a lot of these were introduced with Wi-Fi 6, again 802.11ax. The key factor that was introduced there was something called OFDMA, orthogonal frequency division multiple access. So basically, we're talking about leveraging multi-user MIMO. That's minimum input, minimum output. And also, again, taking that efficiency concept and putting it into what they call variable channel widths, multi-user channel widths. So a great analogy for this, just to keep from boring everyone to death here, is you think about how, just let's compare the bands to a highway, right? So if you think about 2.4, the original, that was probably like a country road, right? Whereas 5 kind of maybe got us into a 4-lane boulevard, right? Well, 6 is now getting us into that 8-lane freeway, like we're talking about, because we have this increased channel capacity. We've got all this new spectrum to play with, but also with OFDMA, we're also introducing an HOV lane essentially, right? So it's kind of impractical from a real world standpoint. But if you think about each lane being a channel, right, and then each truck, you can imagine a truck on that lane that would be your carrier, right? And then these sub-carrier frequencies have what's called resource units. So think of a resource unit as what might be like a package on the truck, right? So, historically, what we had to do was put one customer's equipment on the truck and give them that whole lane, essentially, right? However, with OFDMA, what we're doing is we're basically taking multiple customers' packages and putting them on one truck, and then giving them the HOV lane, essentially. So, with that's what gives us that an enhanced efficiency while also increasing capacity. So the other big analogy I always like to use with wireless is a karaoke bar. So if you imagine, because wireless is a very polite medium, right? It always wants to make sure the air is clear before it sends anything, right? So, and if you imagine the karaoke bar analogy, one microphone at a time, right? So if someone wants to speak and use the air, granted, we can get around that with some of our newer standards that allow multiple microphones through multiple antennas, for example. But really, what you're getting, your goal is still to always be above that noise floor. So that's really what we're getting here with that. The other two things I want to talk about too that are also key features are something called target wake time that was introduced to help make battery devices more efficient, telling devices hey, you can go to sleep if you need to, save power, don't always be constantly transmitting as needed, and also security. It's always top of mind for a lot of people today. So with Wi-Fi 6, they introduced WPA3. So that's another big security standard that's superseded WPA2, which has been around for years now, ever since the beginning of Wi-Fi, essentially. And so WPA3 is a much more higher encryption bandwidth standard that gives us the ability to provide more security around those frames as they're transmitted over the air. And that's kind of a caveat for some people because Wi-Fi 6E, with the introduction of the 6 gigahertz standard, requires that new security standard. So, and there are devices out there that don't support that yet. So, it's something to consider when designing for these new networks.
All right. Well, I love those analogies. I mean, particularly when you're talking about the highway, because again, that's how we think. We never really realized the country road, not just a country road because it's small, it's got potholes and
yeah, exactly.
It's got there are some gravel parts where you turn off the paved road. So it got bumpy and bumpy and bumpy. And now it really does feel like, particularly when you're talking about on the enterprise level, Wi-Fi has gotten very smooth. It's gotten very responsive. It's no longer where you have to sit there and wait. And then you can always tell those organizations that are still on the country road.
Yeah. Well, and there's a lot of configuration factors that go into that too sometimes. So that's where it comes into play to work with a partner such as yourself to really ensure they're getting that, value add service to it and make sure that they're setting it, not only designing the Wi-Fi network properly, but also configuring it in such a way so that you are taking advantage of all these features to help mitigate a lot of that traffic.
All right, so Jorge, let's get you involved in here because obviously, you're talking to a lot of customers out there in the space. Are you seeing Wi-Fi 6 adoption? And if so, why? And if not, why not?
There's been rapid adoption of Wi-Fi 6 hardware and access points. In many cases, some customers have been slow to adopt Wi-Fi 6, but most of the larger K through 12s in the area are buying the new APs and rapidly deploying. They still don't have a preponderance of Wi-Fi 6 clients yet, but we believe that is coming soon. And once they do, they will start to really reap the benefits of the greater efficiency that comes with Wi-Fi 6. Wi-Fi 6 really allows the client that is running a lot of these very highly transactional apps to communicate more efficiently and essentially package data transmissions dynamically and as efficiently as possible so that more data can be transmitted per unit of time.
Obviously, Wi-Fi 6 and 6E, big industry innovation and something that's moving the wireless industry forward. So let's talk a little bit about Aruba and what are some of your wireless differentiators as to how you're leveraging this new technology.
Really glad you asked, Rick. So it's really important to note that, and this might sound a bit braggadocious, but at the same time, we as Aruba are really proud of the fact that we were the first to the market with Wi-Fi 6E capable access points. That was with the debut of our AP 635, which came out back in May of last year. And since then, we've continued to grow that portfolio with 2 additional access points, the 655, which is our, big boy that can handle, very large, high density environments, and also a more entry-level 615, which is not a tri-radio, but it's a dual radio AP capable of flipping between those different bands.
Yeah, we actually call that flex radio.
Exactly.
Our technology for flex switching radio between 5 and 6 and 2.4.
with the goal being flexibility, right? So whether you're a small, medium, or large deployment, we have something that can fit those different size situations, right? Another really cool thing we like to talk about is that the fact that all of our 6E APs today are in fact Wi-Fi Alliance certified and deployed in more than 1,500 accounts already. So it's important to look at that when you're looking at considering other vendors for this solution too, because not all vendors have actually made it to the table yet with that Wi-Fi Alliance. So just be cognizant of that. The other thing I would like to mention too is, our APs are location ready. They have built-in GPS chips to help with what's called, we're calling this a open locate. So it's a way to actually automatically locate your APs on a floor plan by leveraging a GPS radio that can help you anchor it to a physical location. And then there's this new protocol too called Find Time Measurement, FTM, that will let you basically auto-coordinate triangulation between different 6E APs and also our 500 series, which are the Wi-Fi 6 capable APs. So even though those APs don't have GPS radios in them, they can coordinate with a Wi-Fi 6E AP to help locate those devices. And furthermore, because all of our APs come with built-in, IoT radios, Bluetooth, we can do things like help improve location services for clients as well, which is really cool. So yeah, and also in addition to that, all of our APs leverage our smart PoE features. The newer APs now have dual ports, so you can, cable them to more than one switch, as long as you're running loop protection protocols, and be able to do things like hitless failovers. So say a switch dies, it can fail over to the next switch without going down. There's intelligent power monitoring, so that if power PoE capabilities decrease for some reason, we can have the AP radios automatically adjust as needed to accommodate that. So if you run to a limited power budget situation, or maybe turn off the USB port if it's not needed, things of that nature, right? And finally, the other big thing I want to point out too is that since we have such a massive band to play with now, again, 59 channels, we've had to introduce this proprietary feature that we're calling ultra tri-band filtering, and works with another open standard called automatic frequency coordination. That's to help us minimize interference with the 5 gigahertz band. So if you're not familiar, there does exist a very small gap between 5 gigahertz and 6 gigahertz. It's about 50 megahertz wide. So that's huge, because that's important, because if you've got a 6 gigahertz AP on the lower end of that new spectrum and a 5 gigahertz AP running at the upper end of that spectrum, there might be some overlap there. So what this technology does is enable us to automatically coordinate using a platform like Aruba Central to determine those frequencies of those APs and mitigate that interference even further. So that just because you have 6 gigahertz deployed doesn't mean it's going to have a problem with a 5 gigahertz environment. So what that might look like on a map is APA has a lower 5 gigahertz channel versus APB having an upper 5 gigahertz channel with the 6 gigahertz potentially. I think something of that nature. It gets really, really technical. We've got an awesome blog out there that describes how it works. There was some great overseas testing done with our CTO recently. So really interesting stuff to consider. But that's kind of some of the key things that help set us apart. We've got a lot of great resources out there if you're looking for more information on that.
I have to ask this because obviously with every new technology, one of the things that we hear from customers and prospects is my facility going to handle it? What do I have to do? I mean, do I have to bring Chip and Joanna Gaines in here to tear things down to the bare studs and rebuild the entire, whether it be the network or the infrastructure or whatever it is that I have to do? Looking at it from a very high level, what are some of the high level design considerations for 6E?
New spectrum gives us new ways to think about wireless, right? So, and there are, a few key factors that really determine what that design looks like. The RF layout itself, the power requirements and capabilities you have, the throughput levels you need to try and achieve, and operational redundancy, of course, too, being able to have an AP go down while still providing coverage. So, for many years, there has been a lot of great design standards around that and tools such as Ekahau to help design those layouts in the field or predictively with a high degree of accuracy, right? So, but 6E, again, being such a new band with a high throughput capability, gives us this now new consideration to consider for multi-layer designs. So what's really cool about that is, traditionally, you would host your networks, your SSID as it is on both bands, right? Your corporate SSID had to be on both 2.4 and 5 gigahertz, just to make sure if a device couldn't support one, it was available in the other, right? Well, now with tri-band radio access points, we can do things like maybe host just an IoT SSID on a 2.4 radio, and then host your corporate SSID on both 5 and 6, for example, or maybe offer a guest network on the 5 gigahertz, but not the 2.4, right? And that really helps distribute those clients more effectively and forces them to be more, I guess, compatible with a network. Because again, with wireless, you're only as good as your slowest device. So it's really important to keep slow devices contained while enabling faster devices to leverage all the lanes of the highway, right? So so when it comes to design, I would say there's a factor in wireless design called EIRP, effective isotropic radiated power, right? And so that standard is essentially the power of your access point, subtract the cable loss, and add any antenna gains. And that gives you a number, which again, tools like ECHO can help you calculate when you're designing. But the magic number there is 20. So 20 dBm. So if your EIRP is above that number, again, lower is going to be better in this scenario. You might want to consider increasing your EP density to meet those requirements. However, if you're below, then the nuance between those bands is considered minimal for a typical indoor deployment. So, and again, also don't forget security requirements. So again, if you've got clients in your network that don't necessarily support WPA3, I mean, that could be a potential deal breaker until WPA3 is more prolific. However, it makes sense to go ahead and design with that consideration because the adoption rate on this is going to just skyrocket here in the next few years, I'm sure. We were really, really hoping that Apple would come out with the iPhone 14 as a way to, be the first Apple device to really support that. I think one of their newer iPads does support it, but for now, the iPhone is not one of those clients. However, Google's been on top of that with the new Pixels. Samsung's got phones that do it now. There are plenty of NICs out there that can support 6E. So, I mean, again, the adoption is there. It's going to happen. It's just a matter of being ready for it when it does. Also consider location too. So if you have a customer who's in Europe, for example, the full spectrum isn't quite there for them yet. They're still working on getting those additional channels approved. They're roughly about half of what we are at this point, a little under that actually. Yeah. But again, think about it's really pushing people to think in multiple layers now when it comes to wireless. That's the big takeaway.
Yeah, another thing that sometimes comes up is the underlying switching infrastructure.
Yes,
you need to consider whether you have enough power that you can deliver via PoE to the access point. So that really varies by the AP model. The 655 will require in excess of 30 watts. So you're going to need 802.3bt PoE standard at your switchboard. We have ways to mitigate the power needs by using what we call intelligent power management. In the case of the 615, which is more of an entry-level access point, we can actually power the AP with less than 802.3 AF, which is 15.4 watts. So making sure you have the right underlying network infrastructure is critical in deploying Wi-Fi 6 as well as 6E. The other thing to consider is if you're able to achieve higher data rates, you may want to also look for switches that support what's called multi-gigabit and what we call smart rate, where you're able to deliver Ethernet speeds over a copper wire in excess of 1 gigabit per second. So you may need 2.5 or 5 gigabits for each AP. And we also differentiate ourselves by being able to load share. With certain AP models, you're able to connect more than one cable to the access point, in which case you can do PoE power sharing as well as data network load sharing. So that's yet another benefit to some of the AP models we have that include more than one Ethernet port.
Absolutely. Really glad you brought that up because like you said, I mean, that's really important consideration because you don't want the switch to become a bottleneck for wireless, right? Historically it's been the other way around, but now since we're able to exceed the 1 gigabit threshold with some of these access points, you really want to make sure that the switch is capable of supporting that too and delivering the power requirements that some of these beefy access points like the 655 do require. So, we're talking 2.5 gigabit now, 5 gigabit, maybe even 10 gigabit before too long. So, it's really important from a refresh standpoint to consider that. for sure in your switch infrastructure side and power delivery standards.
All of this new technology sounds phenomenal. And I'm sure there are a lot of organizations out there that can really utilize this. But a lot of this, again, comes back down to the user experience. I have to imagine that with this newer type of technology, is it more challenging to ensure that user experience is going as well as it should be?
It can be, absolutely. Anyone out there who works on a help desk can probably tell you that what you said is 100% true. It doesn't matter how good the network is. If the user's having a bad time, nobody's happy, right? So to that end, kind of shifting gears a little, we definitely want to highlight another product we have in our arsenal that can help mitigate some of that, right? So just put yourself in the scenario real quick, where a user calls up the help desk and they're like, "Oh, the Wi-Fi is garbage today," and you're like, "Well, why?" And they can't tell you why. They have no idea, right? And sometimes it's not even the wireless itself; it's something upstream that's having a problem. So what we did was we came with a product through an acquisition of ours called Cape Networks, a really awesome company that we picked up that provided the capability to deliver a sensor. So it's a client-based sensor that kind of looks like an access point, but it really isn't. So just to describe to our users, our listeners, what UXI can do in a nutshell. Again, imagine putting yourself in that user scenario that's calling the help desk. Instead of trying to work with a user and seeing what the problem actually is, you can log into this sensor via a dashboard and see what telemetry it's providing. So it will onboard just like any device on your network. You connect it via wire or wireless or both. We have a power adapter that can connect it to the Wi-Fi. We've got Ethernet for power over Ethernet capabilities to power it up. And again, it will go through every step of that equation. Can I get an IP address, DHCP? Can I get my gateway? And then beyond the gateway, can I get to the internet? Can I resolve DNS? These are all very, very important factors that if one of those things doesn't work, the user is basically hosed, right? So, and beyond that, it provides a great way to get a baseline of your network because it's always sitting there listening and looking at and testing these different metrics. So over time, you start to see what's considered normal or acceptable for your network. And now that we have that information, we can now start to do performance tests, or we can test applications too. Beyond that, the device itself can be configured to look at external websites, things like Netflix doing a speed test, see how throughput looks. It can look at internal websites that you specify. It can ping internal servers. You can leverage a Chrome extension to record your own tests. Go to this website and click this thing. That might be like a key internal website that you want to make sure is always working properly. Just things that can really affect that overall user experience. And again, it's all single pane of glass. A vendor agnostic solution too at that, because what it can do for you is we can use this in any environment. We can say, it's kept separate from Aruba Central on purpose for that reason, even though we do have some integration, because you can go into this dashboard and see groups of sensors. You can create locations and see from a bird's eye view, if a particular location might be having a problem. Or a specific, maybe a site's okay, but maybe one particular sensor within that location is having an issue. So again, it gives you this really great way to monitor sites from a high level standpoint.
And this is something that you had on display that you were demoing at our technology showcase event.
Absolutely. Yeah. People really seem to enjoy it too. It really brought a lot of folks to the table and helped us have that conversation with them. And again, it's one of those, I call it a Trojan horse, because, once people see what it can do and get it in their environment, they may ask the question, well, what else can Aruba bring to the table here? So it's a great conversation starter for us. Absolutely.
Now, Jorge, you see how this, ends up being boots on the ground.
Yeah.
So how would you say, have you seen adoption of this UXI tool, and how would you say that the tool has helped your customers in education sector or other verticals?
So we have a few K through 12 customers in the area that are taking advantage of their UXI sensors to really get a handle on how the network is performing at each one of their locations, each one of their schools. The network administrator can log in the morning, get a global view of the entire school system. They can see green, yellow, red, and hone in proactively on any trouble spots. They can get notified if there's a network performance problem. They're noticing high levels of jitter, delay, packet loss. They may be able to see if DNS and DHCP response times are elevated. They can also look at internal and external tests of applications and servers. So they can actually have the UXI perform a end-to-end workflow where the sensor will log in and mimic an end user and collect statistics and telemetry and basically apply that to an existing or pre-existing baseline and notify the user when a threshold has been exceeded. So now the network administrator is notified proactively that there's some problem on the network that they need to respond to. So it's been very valuable, and the feedback has been overwhelmingly positive.
Again, trying to get that human element out of the troubleshooting equation where possible to help streamline those efforts and just be proactive, like find problems before the users even report them, hopefully.
Yeah, and it really helps with needle in a haystack troubleshooting. When there is an issue, you're able to drill down and look at the data that was collected by the sensor and get a very granular level of data about the problem so that you can resolve the issue as quickly as possible.
We love to be proactive and try to see what any potential objections would be. And of course, one of the main objections that we get is funding. So, Melissa, this is where we're going to call you into the discussion. You've been so patient sitting there listening to everything that's been going on. But obviously, we want to know about some funding options for these exciting new technologies. So if we have a customer like a school system somewhere in the education sector, do they have programs that they can leverage like eRate that would help with purchasing this?
Absolutely. And thank you so much for having me. So just to jump right into eRate and to do a, quick overview of what the program actually is. So eRate stands for Education Rate. And this was created in 1996. And so what it is it provides funding for K-12 schools and public libraries. So just to make sure everyone's aware, this isn't for higher ed. So it's just K-12 schools and public libraries. And they receive this funding through USAC. And so how the structure of the program looks is it's a funding cycle, and it's over a 5-year period. And right now we're currently on the 3rd year of that cycle. The official year starts July 1st, and then it runs through June 30th. And so just to give you an idea with Aruba and eRate and how we did last year, in the 2022 season, Aruba did almost 357 million in eRate sales, and we hit 48 states. So we were very excited about that. But we definitely want to touch on what's eligible for eRate. That way, school districts know exactly if it's eligible or if it's not. And so eRate does have 2 categories. Category 1 is going to be your external connections, and category 2 is your internal connections. So what I really want to focus on today is our category 2. And that's going to be, your access points, your Aruba Central Mobility Conductor, your switches. And something that we're also seeing, and it's fairly new, is our managed services. So this is going to be your HPE GreenLake for Aruba, all of your services. And this is where the UXI sensors are going to fall under. So UXI is, definitely eligible for eRate under managed services. Now, if you're new to Aruba or if you're new to the product or eRate, something we definitely have that is helpful for customers is our eRate SKU lookup tool. And we will provide that for you guys. This way, if you have the part number, you just pop it into this tool. It's public, and it tells you if it's 100% eligible or not. Now, we will also be hosting a webinar with DALY where Megan Coots will be discussing more funding options for K-12, for example, stimulus funding, grant funding. So you're definitely going to want to make sure you check that out.
Melissa, thank you so much, because I have to tell you, when I first joined DALY someone mentioned to me eRate, and I had absolutely no idea what that was. I didn't know who it was for, why it was, how it was. So I think that's definitely something that we could all use in education.
Right. And one thing I also want to point out is, I mentioned that we're in the third year cycle for eRate. And right now, we're seeing the most funding available that we've ever seen since the program started. So right now is prime time to go after that funding. And so, feel free to bring me in anytime if you have any other questions.
Any final thoughts as we get ready to wrap up this episode?
Really just want to emphasize once more, when thinking about deploying this new 6E technology and 6 gigahertz going forward, make sure to just always have that conversation with your partner like DALY to make sure that you're meeting all those requirements on the configuration and as well as the design itself. Make sure to always leverage their expertise to ensure you're getting the best design possible for your network.
Yeah, I would just echo what Anthony said. Proper planning makes a huge difference in the success of your wireless refresh. You're going to need to make sure the pieces are in place before you roll out Wi-Fi 6E.
I agree with Anthony and Jorge. Planning is everything. And Aruba is dedicated to provide, all the knowledge needed for all the types of different funding out there that's available.
Terrific. Well, I want to thank all of you for joining us on the Technology Pulse. Again, I learned a tremendous amount of information today. This was fantastic, and we are certainly very proud to have Aruba as a partner with DALY.
Thanks so much for having us.
Yes,
thanks again to the folks from Aruba for joining us on the DALY Technology Pulse podcast. All right, it's time to wrap things up. The DALY Technology Pulse podcast is produced by DALY Computers, Inc. No portion of this podcast can be reused without our expressed written consent. You can learn more about DALY and our products and services by visiting our website, www.daly.com. Until next time, this is Rick from DALY saying thanks again for listening. Have a great day.